last part from this chapter, which is centroid of a composite volume. Okay, volume meaning that we are in 3 dimensions. So we have the volume. Okay, so the equation, we have these 3 equations, x bar, y bar and z bar. Okay, which is x bar equal to sigma x bar small 1 delta v. V is the volume divided by sigma delta v, and same for the others. The changes is in y bar and z bar. Okay, so if you notice, the equation is quite simple. If we are in line, this one will be delta L, which is for line, and the area, this one will be delta A, and now we are in volume, so this one will be delta V. So it is quite straightforward. So the thing that we need to calculate here is the x bar, y bar and z bar, and also the delta V, the volume for each and every component, in order for us to have the x bar, y bar and z bar for the composite volume here. Okay, so to demonstrate that one, we will go to the first, to this example, which is exercise 13.24. Page, what we have here is page 317. So this example. Okay. So 13.24. Okay, so the question said, determine the centroid, which is x bar, y bar and z bar for the component shown. Okay, and here I've highlighted the component in several different colors. Okay, which is our first step is to identify what is the basic component. Okay, this structure is made up from which basic component, so we have to identify that one in order for us to determine the x bar, y bar and z bar for each and every component. So in here I have identified we have 3 simple components, which is here a triangle here. Okay, and we have this second part, and at the last one is a semicircle. Okay, which is the volume. Okay, so the dimension is given 0.1, 0.3, 0.1. The thickness here, this height is 0.4, and we have r equal to 0.4. Okay, so we know how to calculate the volume of each and every component, and we know where is the location of C, the centroid of each and every component. So we have 3. Okay, 1, 2 and 3 component. Okay, so this is our first step. Every time you got the question, you have to visualize what is the basic component that add up together to make it the big structure. Okay, so you separate the component so that you can first identify what is the value of x bar, y bar and z bar, and calculate the volume of that component to be put in that equation later on, and then you get the answer. Okay, so we do it one by one, which is I have already done here. So, but we go by one. So the first one here, we want to find the small one, x bar, y bar and z bar, and then delta V1. Okay, so the component 1. So here we know that from the table given in this book, okay, for a triangle we know that it is C is here, which is 1/3 from here, 1/3 from here. But it is a volume, so if you want to imagine, okay, we have this is this triangle from previous example. Okay, so you have this triangle, so like this one. Okay, triangle like this one. So we know that it is at this point 1/3 from the length and 1/3 from this length, but it has a thickness, so it must be, the thickness is homogeneous, so it must be at this position from this direction, but here, if this is the thickness, so it must be in the middle here. So this direction is 1/3 over here, 1/3 over here, and from this direction it must be right in the middle. Okay, so that's it. So x bar, this is x, so we have 1/3. So 1/3 times the length given is 0.3, so equal to 0.1. Y bar, as I'm showing to you, it is half or in the middle of this thickness, okay, which is 0.1. It going downward, so it will be negative 0.005. Okay, negative 0.05. And then Z bar is going this way. So from here it is 1/3. So 1/3 what is the length? This is 0. So the radius is 0.4. So it is 0.4 and 0.4. So it can become 0.8. Okay, 0.8, and it is equal to 0.267. Okay, so it is 1/3 from 0.8. This is 0.4 times 2, 0.8. So this length is 0.8. Okay, and then we want to calculate the delta V1, which is this one. This is so half, because it is a triangle, times 0.3 times the length 0.8, and the thickness is 0.1. So you have delta V1. Okay, which is, what is my calculation? I do want to calculate again. So 0.8, 0.3, 0.1, 1 over, so 0.012. 0.012. Okay, and then we go to the second one. Change the color here so you can see clearly. X bar equal to, Y bar equal to, Z bar equal to, and delta V2. If you want to put it in the proper, you can put it X bar 1, 1, 1, and then 2, 2, 2, and so on. Okay, just for your naming that, so that you know which is which. Okay, so X bar for this one, so it is perfectly this one. So we have half from here, half from here, and half from here. So in term of x is positive this direction, so you go backward, so it must be here, half from this distance, which is given to us 0.05, 0.1, negative 0.05, which is going backward. So the thickness, this is the here, but to the back, so it is half from here, so 0.05. Okay, and Y bar is going downward, half from here, which is 0.4 minus 0.2, and Z bar going this direction, half from this one. Okay, so this is Y bar, this is Z bar, X bar is this direction. So this is positive, so half from 0.8, so positive 0.4. Okay, negative, negative and positive, and delta V equal to, so what we have 0.1, 0.8, 0.4. Okay, so that, calculate that one, you will have 0.032. Okay, and then we go to the last one, which is this half circle with the thickness of same 0.1. So we have, okay, X bar 3 equal to, Y bar 3 equal to, Z bar 3 equal to, delta V3 equal to. Okay, so we know that from the table given in the books here. Okay, we know that it is for a circle, it is right in the middle. For the semicircle, okay, it is here. Okay, which is in the equation is write as 4r over pi, which is 4r over 3 pi. Okay, so this is 4r over 3 pi. Okay, so 4r over 3 pi. Here is 4r over 3 pi. This is the multiplication. Okay, so it is half from this one, so here is half from, which is the radius. Here, this is 4r over 3 pi, and the thickness must go in between here, right in the middle here. Okay, so the x bar, again we go backward, negative 0.05. Notice that it will be same for everything here. Oh, this is y bar. Okay, so the x bar, which is here. Y bar, so we're going down, so this is 0.4 plus this one, 4r over 3 pi, which is everything is going down, so I put negative everything. Then 4r over 3 pi, you got negative 5697. Okay, z, which is going this way, half 0.8, so it is 0.4. Okay, z bar is 0.4. And then the delta v, this one. So we have pi r squared. Okay, pi r squared for the whole circle. So we only want the half of it, so divided by 2. Okay, times the thickness is 0.1. So you got here. Okay, 0.025. Okay, now we got everything that we need to be put in the table. Okay, so because we want to do it one by one, delta v times s bar, delta v times y bar, delta v times z bar. So it is a repeated work. Okay, so if you can do it right away here, but I'm afraid that you will lose something, you forgot to do the calculation. So it's better for us to put in the table to not missing anything. Okay, so I put this inside the table. Okay, a simple table here. Push. Okay, so we put inside this simple table. So I have to do it. What every component 3. So 1, 2, 3, 4, and 5. So I have the component, which is start from here 1, 2, and 3. Okay. So this is delta v, x bar, y bar, z bar. Times and times. Okay, so we have delta v, x bar, y bar, z bar, x bar, delta v, y bar, delta v, z bar, delta v. And at the end here, we want to have what? So this is sigma delta v equal to, and here we want to have sigma x bar delta v equal to, okay, so everything, sigma y bar delta v equal sigma z bar delta v equal to. Okay, so put one by one. Okay, so I already calculate, so just put it here. Delta v 0.012, 0.032, 0.025, adding together 0.069. Okay, 0.1, so just copy everything. Negative 0.05, 0.05, so negative 0.05 here, negative 0.2, negative 0.5657. Y bar for the third one. 57. Okay, so we have Z bar 0.267, 0.4, 0.4, and then times everything 0012, negative 0.0006. Negative 0.00125, negative 0.01424, 0.01. Okay, and then you have lastly it is negative 0.00165 or 17, negative 0.0212, 0.026. Okay, so we have all put that in the equation. You will have x bar equal to this one, negative 0.00165 divided by this 0.069 equal to y bar equal to this negative 212 divided by 0.069 equal to, and the last one z bar equal to 0.026 divided by 0.069, and then you have all the answer as here is negative 0.024, negative 0.307, and then 0.377. Okay, so that's it. It is simple. Okay, this part is just a calculation. This part is a calculation. Okay, you put it in the calculator and then you get the answer. Really, just here the question. The one that you need to really look at is this one. Where is the location of the first one is to identify the simple component. To identify this one, and then you need to identify one by one x bar, y bar, z bar, and calculate the volume. X bar, y bar, y bar, and so on. Okay. After this, you just put in the table and do the calculation. Okay, do the calculation. Okay, so this is it. It may take a long time. It's not difficult. It just it will take you a lot of time to do the calculation. If you do it manually, it will take a lot of time. Okay, but the difficulty is not too difficult. Okay, for the difficulties, for me it is not that difficult. Okay, it is really straightforward as long as you can visualize the simple component and where is the location of this one, and then the rest is simple. Okay, that's it. We have arrived to the end of our syllabus. I've covered all and everything. Okay, so I've covered everything in this static made simple. Okay, so I hope it will help you during your study static and other courses later on and in your work.